All right, let's dive into one of the coolest questions in tech. How does a simple idea, a problem you want to solve, actually turn into a real working computer program?
I mean, have you ever had that flash of inspiration for an app and thought, okay, but how does that actually happen? What's the real journey from my brain to my phone screen? How does it go from just a thought to something you can tap on?
Well, here's the good news. It's not some kind of secret magic. It's a totally logical, step-by-step process. And believe it or not, that whole journey starts way before anyone writes a single line of code. It all starts right here. We'll call it the blueprint phase. And honestly, this is probably the most important step of all. It's all about getting a deep, thorough understanding of the problem you're trying to solve. This right here is a huge truth in the software world. Most projects don't fail because of bad coding. They fail because the team never really understood the problem to begin with. Think about it. It's like trying to build a house with the wrong blueprints. It doesn't matter how great your builders are. The house is going to be wrong. So, to get that perfect blueprint, you have to put on your detective hat. You start asking some really basic but critical questions. What are we actually trying to solve here? What information are we starting with? Those are the inputs. And what does a successful result look like? That's the output. And, maybe most importantly, are there any rules or limitations we need to know about? And what if the problem just seems huge? Totally overwhelming. Well, there's a classic strategy that works every single time. You divide and conquer. You just don't try to eat the whole elephant at once. You break it down. And here's what that looks like. You start with a massive goal, right? Something like build a social media app. Kind of scary. So you break it into smaller problems, like handle user logins or let people post updates. Then you break those down even further, and you keep going until you've got a list of simple individual steps. All of a sudden, that huge challenge just becomes a to-do list you can actually tackle. Okay, so we've got our blueprint, we've got our small, manageable tasks. What's next? Well, now we need a plan to actually do them. This brings us to the planning phase, where we create the recipe for our solution. In the programming world, that recipe has a fancy name, an algorithm. But really, it's just a clear step-by-step set of instructions. If you've ever followed a recipe to bake a cake, guess what? You've used an algorithm. It's the exact same idea. Let's make this real with a simple example. Let's say our problem is figuring out if a student passed a class. The recipe, the algorithm, is a super clear sequence. Step 1, get the scores. Step 2, calculate the average. Then, compare that average to the passing grade, which is 60. And last, show the result. See how every single step is crystal clear? There's no guesswork. Now, if the algorithm is your turn-by-turn directions, a flowchart is the visual map of the whole journey. It really helps you see the logic, especially when things start to get a little more complicated. Flowcharts use a standard set of symbols. You've got ovals for the start and end points, rectangles for actions, like doing a calculation, parallelograms for when you're getting information or displaying a result, and the really important one, the diamond. That shape always means a decision has to be made. It's a fork in the road for your program. All right, we have our blueprint and our recipe. Now it's finally time for the building phase. This is the part everybody thinks of, where we start talking to the computer by translating our plan into a language it can actually understand. Code. Yep, at its heart, coding is really just a translation job. You're taking that human-friendly recipe, your algorithm, and you're carefully rewriting it using the strict grammar of a programming language, like C, for example. That's what creates the instructions the computer can follow. But here is a super important point. The best programmers, they don't just write code for the computer. They write it for other people. Or, for themselves 6 months from now. Because someone is always going to have to read that code later to fix it or update it. That's why writing clean, readable code isn't just a nice little extra, it's an absolute professional necessity. And that means following some simple but really powerful rules, like use clear, descriptive names. Student score is way better than just S. Add comments that explain why you did something, not just restating what the code does. Keep your code neat and organized with good structure, not just a jumbled mess. Oh, and keep your functions short and focused on doing just one thing. All of this makes the code so much easier for a human to work with. So we've written our nice, clean, human-readable code. But how does that text file become a program you can actually click on and run? Well, that happens in the final, behind-the-scenes stage, the assembly line. This assembly line has 4 main stops. First, a preprocessor comes through and cleans up the code.
Then the compiler translates it into a more basic assembly language. Think of it like translating a novel into a simple instruction manual. Next, the assembler turns those instructions into the raw ones and zeros that the computer hardware actually speaks. And finally, the linker acts like a project manager, grabbing all the different pieces and tying them together into that one final program that you can run. But let's be real, things almost never go perfectly the first time. So what happens when there's a mistake in our recipe or something breaks on the assembly line? That, my friends, is where every programmer spends a ton of their time. It's called debugging. And you're usually hunting for two main types of bugs. First, you've got compile time errors. These are basically grammar mistakes. You wrote something the computer literally can't understand, so won't even build the program. But the really tricky ones, those are the logical errors. The program runs just fine, no crashes, but it gives you the wrong answer. It's like using the wrong formula in a math problem. This means your recipe, your whole algorithm was flawed from the start, and that makes them so much harder to find. So let's just quickly recap this whole journey. It's a really powerful 4-stage process that takes something from a totally abstract idea to something real you can use. We started by creating a clear blueprint, making sure we deeply understood the problem. From there, we designed a precise recipe, our step-by-step algorithm. Then we translated that recipe into clean code. And finally, that code got put through the assembly line to become the final program. And that brings us to the biggest takeaway here. This whole 4-step process, it provides the structure, the logical framework. But it's just a tool. The real solution, the spark, that comes from human creativity and problem solving. So the next time you use your favorite app, just remember, it didn't start with code. It started with a person just trying to solve a problem. Thanks for listening.